Hello all, welcome back. Today in this class we will solve the problem on force vibration. First we look into the first problem. The first problem it is like this. A machine of total mass 200 kg is supported on a spring of total stiffness 16,000 Newton per centimeter, has an unbalanced rotating element. Please underline this, unbalanced rotating element, which results in a disturbing force 800 Newton at a speed of 3000 rpm, assuming zeta, that is damping factor, is equal to 0.2. Determine amplitude of motion due to unbalancing, that is the first one we have to determine this. Next one is transmissibility, and the third one is transmitted force. So first we note down the data which he has given. So this problem, it is basically on unbalanced rotating system. So the data he has given is machine mass 200 kg. This is the first data he has given, and spring stiffness he has given in the form of Newton per centimeter. So let me convert this to meter, and the unbalancing force is given as 800 Newton, and it is rotating at a speed of 3000 rpm, and we have to assume zeta is equal to 0.2. So these are the important data he has given. So with these data we have to find out these three unknowns. This is the data is given, that is capital M, mass of the system, and K, stiffness of the spring. He has given it in Newton per centimeter. We'll convert this to Newton per meter. And unbalanced force, that is the disturbing force, it is 800 Newton. Speed at which the disturbing force has been rotating or revolving is 3000 rpm, and zeta, damping factor, is 0.2. The first one which we want to find in this problem is maximum amplitude of motion. The formula for maximum amplitude of motion is x max. We know that x max is equal to x naught divided by root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square, where x naught is f naught by k. So by substituting the values in this, f naught value and k value and omega by omega n value, so the omega and omega n is not given. We have to find out omega and omega n. Omega, formula to find out omega is 2 pi n divided by 60. So after substituting the values, that is 2 pi n, he has given it as 3000 rpm. 60 is equal to, the answer which you're going to get after calculating is 314.16 radians per second. In the same manner, to find out omega n, the formula is root of k by m. So we're going to get, by substituting the value of k 16 into 10 power 5 divided by m, which is 200, we'll be getting a value as 89.44 radians per second. So by substituting omega and omega n value and the x naught value in the equation, in the x max equation, we'll be obtaining the value of x max as x max. After substituting all these things, we'll be obtaining a value as 4.378 into 10 power minus 5 meters. And the second thing which we want to find here is transmissibility ratio. So the formula for the transmissibility ratio, as we discussed in the class, is root of 1 plus 2 zeta omega by omega n square divided by 1 minus omega by omega n square whole square plus 2 zeta omega by omega n square. This is the formula for transmissibility. Here we know all the values, even the zeta value is given, omega and omega n. We have found it by substituting the value of all these things in this formula. We'll be getting the value of the transmissibility ratio is 0.151. So since this is a ratio, we don't have any unit here. And the third one which we want to find is what is the transmitted force. This is the third one which we want to find, the transmitted force. So we know that the transmissibility ratio, it is the ratio of force transmitted to the impressed force. So we know the transmissibility ratio as 0.151, force transmitted we don't know, and impressed force he has given in the formula, it has 800. So the transmitted force is 120.9 Newton. These are the three things which is given in the formula, and hence we have found all the three things. Thank you.